So the normal to C at P meets the y-axis at the point A. Okay, so we're going to have a negative reciprocal gradient. Find the y-coordinate of A, given your answer in the form P plus Q log 2. Okay, and so on. So bottom line is the normal to C at point P. So this is point P, by the way. From the previous question, P had these coordinates here, -2 and 4. So let me just note it down here. So P had -2 and 4. And it's telling us this meets the y-axis at the point A. So if this meets at if this equation meets the y-axis at point A, that means, let's just have a look at the axis here. Let's just say, I don't know, this line hits over here. This means that we have an x coordinate of 0. So we know that we have an a coordinate of 0. So let me write that a bit more clearer. So we've got 0 and we're trying to find the unknown, which is y. Okay, so this is quite straightforward. And because it's normal to see at the point P, it just means that the gradient is reciprocated and we have to flip it over with a negative sign. So this means that the new gradient, let's call it m here, will be 1, so it will be the reciprocal, so it will be 2 log 2 minus 5 over 4, and it'll be the negative. So I'll just put negative underneath, just to make it easy. Now, what do we do here? Let me just have a quick look. So we can just write a typical equation. So we need y equals mx plus c. We have the gradient and we have the coordinates. So another thing to note as well is that because it meets the normal at point C, we can also establish the fact that we have a point P. So we can sub in the values of -2 and 4 into this equation and the value of m, and we can get a C. And then hence we can find the value of A. So let's do that quickly. So we can say that the coordinates would be 4 equals, so it will be -4, so it will be 2 log 2 minus 5 all over -4 times x, which is -2 plus c. So guys, unfortunately this has to be in exact form, so we can't just smash this in the calculator. Well, actually maybe you can. No, you can't because of the log 2. So let's have a go. So -2 over -4, let's see. We could of course multiply -4 across, so that will cancel out. So we're going to have -16. Oh, you know what, to make it, actually let's make it easier. So I've already figured it out now. Let's just tidy up this one. So cancelling out the negative signs, these will cancel. Simplify the fraction, this will disappear, and this will be 2. So we've got 2 log 2 minus 5 over 2. Subtracting that across, we're going to have 4 minus 2 log 2 minus 5 over 2. And to keep the fractions the same, we can multiply up and down on the left side by 2. So we're going to have now, let me cross this out, 8 over 2. And then this is, of course, equal to C. And therefore, we can say now that C is equal to, so we can do 8 minus 2 log 2 minus 5. So 8 minus -5 will give us +5. So 8 plus 5 is 13. So it'll be 13 plus 2 log 2 over 2. Not bad. Not bad at all. So therefore, what's our final equation? So we can say now we're going to have an equation of y equals, so that y equals mx plus c, guys. So we're going back to the normal equation. We have a gradient of 2 log 2 minus 5 over -4. Let's just do that. So 2 log 2 minus 5 over -4 x plus c, which is 13 plus 2 log 2 over 2. Not easy. And finally, find the y coordinate of A. So if it meets the axis, this means that x is 0. So we can say therefore, when x equals 0, therefore y equals, so x equals 0, all of this cancels out. So we're left with literally 13 plus 2 log 2. And to keep in this form, well, we can have 13 over 2, so it'll be 13 over 2 plus, and then q would just be 1, so it'll be literally log 2. And that means p is 13 over 2 and q is 1. Not bad, guys. Not bad at all.